All right, let's talk about how do we conduct a test of independence with the chi-square distribution. Now the chi-square distribution is just testing the independency or dependency between two categorical variables. So the data is going to be represented in a table. In this case, for this particular example, we are talking about a 2x2 table with athlete or non-athlete for the rows, and then the different majors as the columns. So what we want to try to figure it out here or determine is if the college major depends on whether the student is an athlete or not, if there is some relationship between those two type of variables. So a survey asked a group of college students about their majors. So they had arts, humanities, and sciences as majors. And then they also asked the students whether they were athletes or not. So you have the athletes and the non-athletes. So each of these cells is the counts of the intersections of the row, which are the athletes, and the column. So for this 17, we had 17 students that responded being athletes and being a art major. 15 of them are athlete and a science major. 24 of them, 9 of them were non-athlete and science majors. At the end, we had 36 students that were art majors, 35 that were in the humanity majors, 24 that were in the science majors. 56 of them were athlete and 39 of them non-athlete, for a total of 95 students. So at the end, the total students that were interviewed or that responded to the survey, it's 95. So the data they collected is recorded in a contingency table. And so they show it below, and we are going to conduct a chi-square test of independency at a 5% significance level. All right, so now when we talk about null hypothesis and alternative hypothesis for a test of independency, the null hypothesis is that our variables are always independent, right? So the null hypothesis is that the two variables are independent, whereas the alternative hypothesis is that the two variables are dependent. So we said that the null hypothesis is that the two variables are independent, so being an athlete does not affect college major. And the alternative hypothesis is that the two variables are dependent, so being an athlete does not affect college major. All right, so null hypothesis and alternative hypothesis for the test of independencies will always read the same in terms of the null hypothesis is always they are independent, and the alternative is always that they are dependent. So we're going to do the test. So when we do the test, we are going to use RGuroo to do this for us. So the difference in here is that we need to enter the data to RGuroo, because this is a table. So you go to data, you go to data input, and you're going to create a new table. Okay, so careful here. We are not creating a new data set. We are creating a new table, because we actually have rows that have names and we have columns that have name. So we create a new table. So here is, so we need, without the totals, we have 2 columns and we have 3 variables. All right, so the columns are athletes and non-athlete. All right, I'm going to rename my variables in the top here. So the first one is arts. The second one is humanities. And the third one is science. So once we have that, we're going to enter the value. So this is 17. And if you go tap, it will move you to the next one. 24, tab 15. And then down here, we have 19, 11, 19, 11, and 9. All right, so that's what you need, the 2 rows for athlete and non-athlete. And then you need the 3 majors, art, humanities, and science for the columns. So we need to put labels. So the row label is going to be athlete, because that's the question, whether you are an athlete or not. The column label is going to be majors. And the variable name, this is what we have in each of the rows. It's number of students. So I'm just going to write number in here. We need to save this. So I'm going to save this as major athlete, just to kind of have an idea of what my data set is when I am working on this. So the data set major athlete has been saved successfully. So again, when you are going to do this, you go to data, you go to data input, and you go to create a new table. Once we have that table created and saved, we go to analytics, we go to analysis, and here we need to go all the way down to contingency table. The contingency table is going to help us to do the analysis of 2-way contingency tables to test for independency. So we go here, we're going to choose that major athlete data set, data table that we created. We're going to choose the factors. The order doesn't matter. We just need to have one as factor 1 and then the second one as factor 2. Doesn't really matter the order. The frequency, we're going to choose the number so it counts that the cells that we say in here. We use the number. If we use number of students, that is your frequency. So this number in here is just the label that we use in here. All right, so once we have that, we want to do a chi-square, and then we make sure that we have a significance level that we want is a 5%, so we're good. And we click the I to get our result. So again, here, this is the same table we have. So 17, 24, 15, 19, 11, 9, which is what we enter. When we do this analysis, the contingency table, the contingency test, the table, it's going to add the columns and add the rows. And now you see that this whole thing that I have in here is the same thing that Newton gave me. But when you create the data set, you don't need to add the totals, just the counts for your rows and columns. The total is going to be added by RGuroo when you conduct the test. So here is a chi-square test of independency. So we need the test statistic here, rounded to 1 decimal place. So your test statistic is this friend in here, and this in here is your p-value. So the test statistic is going to be 3.5 rounded to 1 decimal place. All right, and so if we continue here, this is just the formula when we do it by hand, so we don't need that. To determine the critical value, we need to look at this table. So the degrees of freedom is 2, and it's given to you by RGuroo. So then you have to go here to the degrees of freedom 2. So you're going to look at this row, and you're going to look at your significance level. So we are working with a significance level of 0.05. So when you have 2 degrees of freedom, the critical value for a 5% significance level is 5.991. So I'm going to put the whole thing in here, 5.991. All right. So again, the degrees of freedom. The formula for the degrees of freedom is the number of columns minus 1 times the number of rows minus 1. So when you do number of rows, which is 3 minus 1 is 2. So we have 2 in there. And then when we do numbers of the number of rows minus 1, we have 2 rows minus 1, that's 1. And so when you multiply 2 times 1, that in right there is your degrees of freedom. And then we use the same significance level that we are using because a chi-square is it only has 1 tail. the shape of the chi-square only has one tail, so we don't have to worry about dividing the alpha in two as we do with the z when we use the normal distribution, or with the t when we use the t-student distribution for example, the hypothesis of the means or proportions that I have shared videos before. Right, the formula is just right here. See, number of rows -1, number of columns -1, and then when you do the multiplication, you get that too. All right. All right, so then we need to make our conclusion here. So here we have a p-value. So we have a 0.17291 as a p-value. Our significance is 5%. So the test is not significant at the 5%, meaning that we should not reject the null hypothesis. And if we do not reject the null hypothesis, it's because at the 5% significance level, there is not sufficient evidence to conclude that being an athlete affects college majors. And with that, I conclude the discussion of how to perform the test of independency with a chi-square distribution using RGuroo. And I hope this is helpful. Questions, you can drop them in the comment or send me an email if you happen to have my email.